The transition from Optimus 2.5 to Gen 3 is especially significant because Tesla itself has called Gen 3 its first design intended for mass production. The company has said that Gen 3 would bring major improvements over version 2.5, including its newest hand design. Tesla also stated that preparations for the initial production line were already in progress, with supply chain readiness being developed alongside the factory. Production is expected to start before the end of 2026, with an eventual target capacity of 1 million robots annually. That is a completely different situation from producing only a few hundred demonstration units. A goal of 1 million robots per year means Tesla is already approaching Optimus as a product that must be manufactured on an automotive scale. For comparison, Tesla produced 1.65 million vehicles in 2025. A single Optimus factory, designed to produce 1 million robots each year, would therefore theoretically approach the scale of Tesla's entire current annual vehicle output. And Tesla's plans go even further. In its Q1 2026 update, Tesla said preparations for its first large-scale Optimus factory would begin soon. The first production line, designed for 1 million robots annually, is planned to replace the Model S and Model X production lines in Fremont. At the same time, Tesla said it was preparing Gigafactory Texas for a second-generation Optimus production line with a long-term annual capacity of 10 million robots. That 10 million figure changes the picture dramatically. If Tesla actually reaches 10 million robots per year, it would be producing more humanoid robots annually than the entire existing humanoid robotics industry has produced over many years. And that is exactly why Optimus should not be seen as just another Tesla product. Tesla is attempting to build the manufacturing infrastructure for an entirely new class of machine. The company has also established a formal milestone connected to the scale of the business. Tesla's 2025 proxy materials define 1 million bots delivered as at least 1 million AI-powered mobile robots manufactured by or for Tesla, including Optimus and future successors or improvements. That detail is especially interesting because Tesla isn't restricting the definition to one particular Optimus generation. Instead, the company appears to be treating the bot as an ongoing product platform. Gen 3 could eventually lead into Gen 4, Gen 5, and later versions without changing the basic business model. This fits with Elon Musk's much larger prediction about Optimus. Musk has said that his prediction is that most of Tesla's long-term value will come from Optimus. That's a remarkable statement because it suggests he doesn't view Optimus as a side business next to Tesla's vehicles. He sees humanoid robotics as potentially one of the company's biggest sources of future value. And there is a reason Tesla believes it can pursue that goal. Musk has explained that the technologies Tesla has developed for its vehicles, including batteries, power electronics, advanced motors, gearboxes, software, and AI inference computers, can all be applied to a humanoid robot. Tesla has made essentially the same argument while presenting Optimus as part of its larger AI and robotics strategy. That means Tesla could potentially transfer years of automotive engineering experience directly into robotics. The batteries developed for electric vehicles can provide energy storage. Advanced motors can generate movement. Power electronics can control those motors. Gearboxes can transfer mechanical force. AI computers can handle perception and control. And Tesla's experience with high-volume manufacturing can potentially be applied to the robot itself. But there is another piece of evidence that makes the strategy even more fascinating. At Tesla's CVPR 2026 event, the company described its robotics research as involving foundation models for robotics, with large multimodal models controlling robots through an end-to-end pixels-to-actuation system. Tesla also said its work includes architecture, data, training, evaluation, safety, and reliable real-world deployment. This suggests that the real Optimus strategy isn't simply about creating a better mechanical body. Tesla is attempting to connect the entire technology stack: robot hardware, AI models, training data, simulation, physical world feedback, and mass production. And this is where the evolution from Gen 3 to Gen 4 and Gen 5 becomes important. Each generation could potentially improve the physical hardware, while the AI system continues learning from an expanding fleet. The more robots Tesla deploys, the more real-world situations it can potentially capture. The more data Tesla collects, the more the next generation can be trained and improved. So when Tesla discusses 1 million robots, and then a production line designed for 10 million robots per year, those figures shouldn't be viewed as simple factory targets. They represent a much larger objective. Tesla is trying to transform Optimus into a continuously evolving product platform, where Gen 3 establishes mass production, future generations improve the hardware and intelligence, and increasingly large factories make those improvements available to millions of machines. That is why Gen 3 could become much more important than simply being the next version of Optimus. Gen 3 could be the point where Tesla stops demonstrating that it can build a humanoid robot and begins proving that it can manufacture an entire population of them. Optimus Gen 3 and real-time 3D mapping. How will it actually understand a house? Imagine Gen 3 entering a home that it has never encountered before. There are no factory lanes, no predetermined robot routes, and no guarantee that objects will stay in the same position. A chair could be moved into the center of a room. A child's toy could be lying on the floor. A dog could be sleeping in the hallway. And a person could suddenly walk directly in front of the robot. Gen 3 therefore cannot depend on a fixed map. It needs to constantly build and update an internal representation of its surroundings while completing its task. Tesla already has an important technological foundation for this. Its vision networks analyze camera images for semantic segmentation, object detection, and monocular depth estimation. Meanwhile, its bird's-eye view networks process video from multiple cameras to generate information about road layouts, static infrastructure, and 3D objects from a top-down perspective. Tesla says a full version of its self-driving neural networks uses 48 neural networks, requires roughly 70,000 GPU hours for training, and generates around 1,000 different tensors, or predictions, at each time step. For Gen 3, the important point isn't that Tesla can simply transfer FSD directly into a humanoid robot. The key advantage is that Tesla has already spent years developing systems capable of turning visual information into a detailed representation of the physical world. Tesla explicitly says its autonomy algorithms build a representation of the world and plan trajectories inside that space, while its neural networks learn from scenarios collected from a fleet of millions of vehicles in real time. Tesla has also confirmed that it is applying its self-driving AI experience to Optimus. In its filings, the company says it is applying AI lessons from its self-driving technology to bots such as Optimus, while describing Optimus as a general-purpose autonomous humanoid robot. This matters because it indicates that Gen 3 isn't being developed separately from Tesla's vehicle AI program. The same broader expertise in perception, planning, training, and inference could potentially help the robot understand its surroundings. But recognizing a room is not the same thing as understanding it. Gen 3 might identify a small object on the floor, but it still has to determine whether that object is a toy, a pillow, clothing, something fragile, or an obstacle. The correct response depends on the situation. A child's toy may need to be picked up. A glass object may need to be avoided. A sleeping dog shouldn't be treated like an ordinary inanimate object. The robot therefore needs to connect visual recognition with spatial reasoning and the goal of the task. The challenge becomes even greater when the environment changes. Imagine Gen 3 carrying a glass from the kitchen toward a table when a child suddenly runs across its path. The original route is no longer safe. The robot must detect the child, understand that the person's position is changing, calculate a safer path, maintain its balance while changing direction, protect the glass in its hand, and then continue toward the destination. Tesla's autonomy research already focuses on planning and decision-making in complicated real-world situations involving uncertainty, which is exactly the kind of challenge a humanoid robot encounters once it leaves a controlled factory environment. That is why the real goal for Gen 3 is much larger than simply installing better cameras. The robot needs a continuous cycle of perception, spatial representation, prediction, planning, and physical action. It must turn what its sensors detect into an understanding of its environment, use that understanding to select a trajectory, perform the movement, observe what has changed, and then update its decision. So how quickly can it actually operate inside a home? The real test for Optimus Gen 3 isn't simply whether it can walk. The bigger test is how quickly it can complete normal household tasks without requiring constant human supervision. Tesla is moving toward a robot capable of operating continuously in an environment where every task can change from one moment to the next, carrying objects, cleaning, organizing, moving through rooms, responding to people, and adapting when something unexpected happens. One major advantage is the improvement in reaction and movement control. Gen 3 is being developed to move more naturally, maintain its balance more effectively, and respond more quickly to changes in its surroundings. That becomes especially important when the robot is carrying something while moving through a home. If someone suddenly steps into its path, Gen 3 needs to slow down or change direction immediately instead of stopping the entire operation. The source material specifically points to faster reactions, better balance, locomotion, and adaptation to unexpected environmental changes as important areas of development. The more interesting question is what Gen 3 could actually accomplish with those abilities. In a kitchen, for example, the robot could potentially move between the refrigerator, countertop, sink, and dining area while completing a sequence of tasks rather than carrying out one isolated action. In a living room, it could move around furniture, recognize objects left on the floor, place items where they belong, and continue working even while people move around it. The key is that the robot has to coordinate perception, movement, and decision-making continuously instead of treating every action as an entirely separate command. Tesla's training approach makes this even more interesting. Optimus can reportedly be trained for as much as 16 hours per day through demonstrations, video, simulation, and repeated physical practice. That means Tesla can train the robot on specific household behaviors and gradually improve how efficiently it performs them. A task that initially requires slow and careful movements could become smoother and faster after thousands of repetitions. And this is where time becomes an important measurement. A household robot doesn't need to perform one impressive 10-second demonstration. It needs to work for hours, repeat tasks many times, recover from mistakes, and continue operating without someone constantly resetting it. The source describes Optimus as targeting roughly 8 to 16 hours of operation depending on workload and battery configuration, giving Tesla a much more practical goal than simply showing that the robot can move. Imagine a robot spending the morning organizing a room, moving objects between different locations, helping with household preparation, responding when someone calls it, and then returning to its charging station when its energy becomes low. The real breakthrough isn't any single task. It's the ability to connect many tasks together while continuously adapting to the environment. That is ultimately what Gen 3 needs to demonstrate. Speed isn't only about how quickly Optimus moves its legs. It's about how quickly the entire system can understand a situation, decide what needs to happen, perform the action, recover from unexpected events, and move on to the next task. If Tesla can make that entire cycle reliable, Gen 3 could become the first Optimus generation that feels less like a machine performing demonstrations, and more like a worker capable of completing an entire shift inside a human environment. And that could be the moment when Optimus moves from an ambitious robotics project into something much closer to a practical product. What do you think about Tesla's Optimus Gen 3 and its potential to operate inside real homes? Let us know your thoughts in the comments. If you enjoyed this breakdown and want to see more updates about Tesla, Optimus, AI, and the technology shaping the future, make sure to like the video and subscribe to the channel. Thanks for watching, and we'll see you in the next one.